For as long as we've been around, the ground beneath our feet has held this terrifying power, right? The earthquake. And trying to predict them has always been the holy grail of seismology. But what if the key wasn't buried deep in the Earth's crust, but was actually floating high above our heads? That's the mystery we're digging into today.
I mean, this is the ultimate question. It's a question that carries the weight of millions of lives, the fate of entire cities. And for decades, the answer has just been this frustrating no. But, that might finally be changing, all thanks to a group of scientists looking in a very, very unexpected place.
Yeah, you heard that right. Instead of listening for the rumblings deep inside the Earth, some researchers are actually tuning into these strange signals happening in the sky. And I know, it sounds kind of out there, but the data is starting to reveal this fascinating link between our atmosphere and the ground we walk on. So our investigation really kicks off in a place most of us never think about, the ionosphere. This isn't just empty space up there. Nope, it's a super dynamic, electrically charged part of our upper atmosphere, and it just might be holding the clues we've been searching for all this time. Okay, so what exactly is the ionosphere? The best way to think about it is like Earth's electric blanket. It's this huge layer in our atmosphere where energy from the sun is so intense that it literally rips electrons off of atoms, creating this sea of charged particles. This plasma, as it's called, is the reason your GPS works and how radio signals can bounce all the way around the world. And it's not just one big blob up there either. It's structured, almost like an onion. You've got the D layer, that's the one closest to us. Then you move up to the E layer, and finally you hit the F layer, which stretches way out towards space. Each of these layers interacts with our technology in different ways, and that's absolutely crucial for how scientists can even observe it. And this is where our detective story really gets going. See, scientists who were monitoring this electric layer started noticing something weird. These disturbances or anomalies that just didn't seem to be caused by the sun or any other normal space weather. They seemed to be coming from Earth itself. Now here's the kicker, the timing. We're not talking about a warning that comes minutes or even hours before a quake. The research is showing signals that pop up days and sometimes even weeks beforehand. I mean, can you imagine? That's the kind of early warning that would be an absolute game changer. So the specific thing these scientists are tracking is a change in what they call the total electron content, or TEC. Basically, it's like a sudden, localized thickening of that electric blanket we talked about, happening right over a spot where a major earthquake is about to strike. So how in the world do you see an invisible surge of electrons? Well, researchers have gotten really clever. They use the very same GPS signals our phones use to build these amazing 3D maps of the ionosphere. They also act like detectives, listening to how radio waves bounce off it. Any weird fluctuation could be a clue that the TEC is changing. But wait, the plot thickens. The clues aren't just in the ionosphere. At the same time scientists were looking up, another group of researchers was looking down from space, and they found a totally different kind of signal that seems to be another piece of this same incredible puzzle. This second anomaly is all about heat. Satellites have detected a subtle but really distinct increase in temperature right on the ground directly over a future epicenter. It's almost like the Earth itself gets a slight fever before the big quake hits. And they spot this using these unbelievably sensitive infrared cameras on satellites. They can even track how fast the ground cools down at night, so if an area stays unusually warm long after the sun goes down, it gets flagged as a potential thermal anomaly. It's pretty amazing. All right, let's just pause here for a second. We've got two very different types of clues, right? One is electrical, happening way up in the atmosphere. The other is thermal, happening down on the ground. So the big question is, how could they possibly be related? This is the central mystery that researchers are now trying to solve. This diagram here really lays out the leading theory. It all starts deep, deep underground, where immense stress is building up in the rocks. The idea is that this stress forces the release of charged particles and gases. Now, as you can see down at the bottom, this could be what's causing those thermal hotspots on the surface. Then, as those charged particles rise up through the atmosphere, they disturb the ionosphere, and voila, that's where you get the TEC anomalies at the top. So they're not separate things. They're two symptoms of the same cause. So just to recap it all, on one hand, you've got TEC anomalies. That's an electrical signal way up in the atmosphere.
On the other hand, you've got TIR anomalies, a heat signal down here on Earth's surface. But the crucial part, the thing that ties it all together, is the timing. They both appear days to weeks before the event, and that consistency is what makes this whole theory so compelling.
So we've got the clues, we've got a theory that connects them. What does this all mean? Where does that leave us? Are we actually finally on the verge of having a reliable earthquake forecasting system?
Look, the bottom line is that this isn't some fringe theory anymore. Study after study, looking back at major earthquakes, have found these precursor signals. The correlation is strong, it's consistent, and it really demands serious attention from the scientific community.
But, and this is a really big but, we have to be clear. This is not a working prediction tool that's ready to issue public warnings tomorrow. It's a hugely promising field of research for sure, but scientists still have a lot of work to do to figure out how to filter out false alarms and turn these signals into a forecast you can actually count on.
But the evidence is pretty stunning, isn't it? We have heat signals rising from the ground and electrical signals buzzing in the sky, both showing up weeks before a disaster strikes. The question really isn't if there are warning signs anymore, it's how quickly can we learn to read them? Could this finally be the breakthrough that lets us predict the unpredictable?